session is going to be on math. For Math 1314, we'll be over synthetic division and complex numbers. For Math 1324, we'll be covering solving exponential and logarithmic equations. Thank you for coming to TVE Happy Math Hour, presented by Yvette Chuka, Ruben Carrizales, and Alberta Zassi. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come and watch it. Thank you. So now at this time, we ask that you please mute your mics for the best sound experience. Otherwise, the feedback could interfere with the information we'll be sharing with you today. So without further ado, here is Miss Yvette Chuka.
Hello, everyone. Welcome to Friday Happy Hour or Friday Happy Math Hour. Just a reminder, if you are taking 1324 or 0324, Ms. Salazar just put a link so that you can go to that session by clicking the link. But for those of you that are here for 1314 or 314, today we're going to be talking about synthetic division and complex numbers. And synthetic division is from section 2.3, and the complex numbers are from section 2.4, which is what's being covered in our classes this week. So at any time, if you have any questions, just feel free to put it in the chat. So here we have a graph, and one of the things that I just want to highlight here is if we have a polynomial that looks like this, we can look for the factors. And if we solve each factor for x, then you can see here, for example, that one of the zeros is at x equals 2, which I circled here. If you know that x equals 2 is a 0, then you automatically will know that x minus 2 is its factor. And later in 2.5, we're going to be looking at these factors in more detail. Okay, so before we do synthetic division, I wanted to just talk about long division first and give you some examples there. In order to do long division, there are some kind of not rules, but process that you want to follow. And one of them is to arrange the terms for the dividend and the divisor in descending orders, in descending power. For example, the highest power wants to be first and then followed by the smaller ones. Then we're going to divide the first term by the second term. And so really what's going to happen here is, let me just show you a quick example. Let's say you had the number 172 and we're dividing by 3. Then if you ask yourself, how would you divide this? Some of you might say, well, how many times does 3 go into 17? And so we would normally put a 5 because that's how many times it goes in. And then what would be your next step? So just think about what you would do next. And so for some of us, we would say, okay, well, 5 times 3 is 15. So we write the 15 below the 17. And then what do we do next? We subtract, right? And so we get a 2. And what's the last thing we're going to do here? We're going to bring the 2 down. And then the process starts again. Okay. So this process is going to be the same for dividing polynomials. And so on the next slides here, I have the process just written in words. So I'm going to go just skip through these since the best way to do it is to actually do the problem. So here we have a polynomial, degree 3, and we want to divide by 4x minus 3. So the first thing you want to make sure is that these are in descending order. And so here we have 20x cubed. So we have a 3, and then we have a power of 2, a power of 1, and then we have our 6. And then our divisor is also the same. So we're ready to divide. So what we're going to do is we're going to ask ourselves that same question. How many times does 4x go into 20x cubed? And some people will look at this easier if they ask themselves to divide the first term of the dividend by the first term of the divisor. Okay. But one of the things that I like to ask myself is, what do I need to multiply 4x to get a 20x cubed? And so the answer here is 5x squared. Okay, so we're going to place our 5x squared up here on the top. And now, just like we did with the other problem, we're going to multiply. So we're going to take 5x squared times the 4x, and we get 20x cubed. And then 5x squared times negative 3 is negative 15x squared. Okay. So we need to subtract, but notice here that I put parentheses around my 20x cubed and my negative 15x squared because we're subtracting the entire thing. Okay. So I'm going to go ahead and distribute that negative in here. So we get negative 20x cubed plus 15x squared. And so now we're just going to add them together. And we get 20x cubed minus 20x cubed is going to be 0. And negative 35x squared plus 15x squared is going to be negative 20x squared. We're going to bring down our 23x. And then we're going to repeat the process. Okay, so we're going to ask ourselves, how many times, or what do I need to do to 4x to multiply to get a negative 20x squared? Okay, so I'll put it on this side. So if you notice here, in order to get this negative 20x squared, I'm going to multiply by negative 5x times 4x, and I get negative 20x squared. And then we have negative 5x times negative 3 is going to be, let me see, I lost my place here, 15x. Okay, so I have my result here, but remember we have to subtract. So we're going to distribute this negative times a negative. It's going to make that a positive 20x squared. And negative times a positive 15x will make it a negative. Okay, so we have it right here. And so if we add these together, then that's 0. And 23x minus 15x is going to give me an 8x. And then I'm going to bring my next number down, which is negative 6. So again, the process, we ask ourselves, what do I need to multiply 4x to get a 8x? So I need to multiply it by 2. So 2 times 4x is 8x, and then 2 times negative 3 is negative 6. But since I'm subtracting, it's going to change the signs for both of these, giving me a 0. Okay. So once we have a number or a power less than what we're dividing by, then we know we can stop. And so let's talk about what these numbers mean. The last number you get here is called your remainder. The numbers you get at the top here is your quotient. And then what you're dividing by is called your divisor. And this middle term in here, which is being divided, is called your dividend. When you enter your answers in WebAssign, they want you to enter the answer as a quotient plus the remainder divided by the divisor, which is right here in red. So here's your quotient, 5x squared minus 5x plus 2, plus your remainder of 0 divided by 4x minus 3. Now in WebAssign, since 0 divided by 4x minus 3 is 0, in reality, you just need to enter your answer as 5x squared minus 5x plus 2. Okay. Now these methods here are going to be useful when you're trying to find your zeros, because one way to find your zeros is to factor or use the quadratic formula, but not everything factors and not everything is quadratic. And so we're going to be using these methods to kind of help us break it down into something that is quadratic. So synthetic division, in my opinion, I prefer synthetic division over long division. And in order to use synthetic division, your divisor has to be in this form, x minus c. If it's not in that form, you can still use synthetic division if you write it in this form. Okay. So let's look at an example. So here I have a polynomial, and it's being divided by x minus k. So the first step is you still have to arrange your terms in order from decreasing order. And then you need to identify the coefficients. Remember, the coefficients are the numbers in front of your x's and your constant. Okay. And then we're going to write k on the outside, and then we're going to make this little box around the k and the coefficients. Your coefficients you're going to place like I did here. And then the first step is going to be to bring down the a, or bring down your first number. And then we're going to multiply the k times the a, and whatever you get, you're going to place on the second column. Then you're going to add the ka plus the b, and then we write it below the line. Okay. And then you continue the same process. So you would take k times b plus k times a. Whatever answer you get, you would place up here below the c. Okay, so it's just going to take the same process. So let's look at it as, well, we'll do an example here in a second, but this last number you get, that's going to be your remainder. Okay. And the numbers before that is what's going to make up your your quotient. So let's try an example. So if we have use synthetic division to divide x squared plus 5x plus 6, and then we're going to divide by x minus 1. This is quadratic, so you could easily, find a zero by factoring or doing a different method. But here they want us to divide. So the first thing you want to do is identify what is k. So does anybody want to write down in the chat what you think k is for this example? Okay, so k is going to be 1, right? So this is going to be your 1. And we're going to place it on the left side. Then we're going to list the coefficients. So in front of x squared is a 1, in front of x is a 5, and then we have the 6. So I'm going to write those numbers in here. And then my first term is to bring down the 1. And then I'm going to multiply 1 times 1. And whatever I get, I'm going to place up here. So we multiply, then we place our answer here. Then we're going to add 5 plus 1 is 6. And then we're going to continue the process. So 1 times 6 is going to be 6. So we write down our number. And then 6 plus 6 is going to be 12. Okay. So let's see what our answer is going to be here. So the last number is your remainder. And then the next two numbers to the left are your quotient, what makes up your quotient. So here, we're going to have your dividend, your divisor, but our answer again, we want it to be written as your quotient plus your remainder divided by the divisor. Now your quotient, when you write it out, you're going to start with 1 degree less than the dividend. So your original problem, you had a degree of 2. So when you start writing your quotient, you're going to go 1 degree less. So for this one, we would write it as x, and notice the degree is 1 and then we would have a plus 6, and then your remainder divided by the divisor. Okay, so I would enter this in red into my answer for WebAssign. So let's try another one. This is a little bit bigger. So again, here we want to identify what k is, and k is 8. So we're going to write the 8, and then we want to make sure that our terms are in descending order, which they are. So I'm going to take the coefficients, and I'm going to list them here. So we have 4, 36, 36, and negative 32. My first step is to bring down the 4, and then I'm going to multiply 8 times 4, which gives me 32. And then we're going to add. So 36 plus 32 is 68. And then 8 times 68 is going to be 544. And then we're going to add it to the 36. And so we end up with 580. And then we continue. So 580 times 8. And then that's going to give us 4,640 plus the negative 32. And so we end up with 4,608. So if you don't get a remainder of 0 here, then in the next section, that is not a good thing. But if you end up with a 0 here, that's going to be like the best thing ever. But you'll see that in the next section 2.5. Okay, so for now, we identify our quotient and remainder. So the last number is your remainder, which is right here. And then your quotient, we have a 4. Remember that it's going to start with 1 degree less. So if your degree was 3, now we're going to start with a square. So we're going to have 4x squared plus 68x plus 580 plus your remainder, 4,608, divided by your divisor, which is x minus 8. Okay, let's go to another one. All right, so here we need to identify k, and we also need to make sure that our dividend is in the descending order. And you can see here we have a 3, but then we go to the power x power of 1 and then of x power of 2. So we need to rearrange these terms. So let's go ahead and do that. So we would end up with 3x cubed plus 21x squared minus 6x minus 42, and then divided by x plus 7. In order to use synthetic division, remember I mentioned that your divisor has to be in the form x minus k. So since we have x plus 7, we can easily write it as x minus negative 7. Okay, so if we write it as x minus negative 7, then we can identify k. So k here is going to be negative 7. Okay, so for some people, they like to say, well, if it's a positive 7, then I use a negative 7. If it said x minus 7, then I would use a positive 7. So now in here, we're going to write our coefficients, which are 321, negative 6, and negative 42. Then we're going to bring the 3 down. Negative 7 times 3 is going to give us a negative 21. And then we add it to the positive 21, so that gives us a 0. And then negative 7 times 0 is 0, plus a negative 6 is negative 6. And then negative 7 times negative 6 is a positive 42. And then if we add negative 42 plus 42, we end up with a 0. And that's going to be some great news in the next sections. And I'll tell you why here in a second. So our quotient is going to be 1 degree less. So we have x cubed. So 1 degree less would be a 3x squared. And then we don't have an x, right? So we have a 0x. And then a minus 6 plus your remainder of 0 divided by the divisor. And you can simplify here. You don't have to leave it as 0x. You can just get rid of that. And so this would be your answer that you enter into the WebAssign. Okay. But let me tell you just really quick, kind of a sneak peek into the next sections. Whenever you do get a remainder of 0 here, then what that tells you is that this number here is going to be a 0. Okay. So at negative 7, let's say negative 7 is here. This tells you that we're going to have a 0 at this location. Okay. And so in the next section, we're going to have to find these zeros. All right, so let's go to one more. So x cubed minus 3x squared plus 6. So I'll give you about 30 seconds to, in your mind, think about two things. Number one, what is your k? And then number two, what are the coefficients that you're going to write in that box for us to do the synthetic division? Okay, so I'm going to give you about 30 seconds. Just think about it. And then you'll see, compare what you were thinking to what I'm going to show you here. Okay, so K, what is K going to be? 5. Okay, so K is going to be 5. And then your dividend is going to be, we have x cubed minus 3x squared, but then there's no x, so we still need to use a placeholder, which is going to be 0. And then we have our 6. So when you write it out, you're going to have your 5 there. And then your coefficients would be 1, negative 3, and don't forget that 0, and then the 6. Okay, a common mistake is people will leave the 0 out, and so their answer is going to be incorrect. So then we continue, bring down the 1. 1 times 5 is 5. plus a negative 3 gives us a 2, and 5 times 2 is 10. 10 plus 0 is 10, times 5 is 50. And so then that's going to give us 56. And so what this tells us is that 5 is not going to be an x-intercept. It's not a 0. So my quotient is going to be, here's my 1. I'm going to start with 1 degree less. So I'm going to have x squared plus 2x plus 10. And then our divisor, our remainder, 56 divided by our divisor. Any questions on that one? Okay. So now the next little section that we're going to have here is called the remainder theorem. And it tells us if a polynomial f of x is divided by x minus k, then the remainder is going to be r equals f of k. And so you'll see what it means here with the next example. So you have f of x equals 2x cubed minus 7x plus 2. And it says use the remainder theorem and synthetic division to find each value. So I'm going to start with synthetic division. And so here they tell me that given f of 1, so here we know that x is equal to 1 because whatever's in the parentheses, that's your x. So that your x is going to be on the left side here, that's your k. So whatever number is inside is going to be your k. And then my coefficients are 2. I don't have an x squared, so that's 0. And then my negative 7, and then my 2. So if we do the work, then we bring down the 2, multiply by 1, so we get 2, and so on. Okay. Now notice here that your remainder is negative 3. So this is using synthetic division. Now we use the remainder theorem. What that's going to tell us is, and to use the remainder theorem, all we're going to do is substitute the 1 in for every x. So I'm going to have 2 times 1 cubed minus 7 times 1 plus 2. So we get 1 cubed is 1 times 2 is 2, and then minus 7 plus 2, and that gives me a negative 3. So you can see here that negative 3 is the same answer that we get. So to find the remainder, you can use synthetic division, or you can use the remainder theorem. Okay, so for letter B, same idea. The negative 2 is what goes on the outside. We have our coefficients, and then here we ended up with remainder of 0. So that tells me that x equals negative 2 is 0. And then if we do the remainder theorem, you'll see that you get the same answer for both of these. Okay. So how does synthetic division help us solve these equations? So I'm going to give you an example. So it says find the zeros for the given function, given that x equals negative 2 is 0. So if you notice, your function here is 2x cubed minus 7x plus 2. So if you want to find the zeros, that means that we're solving for x when we let y equal 0. And since this is not quadratic, we're not able to find, we're not able to use the quadratic formula or factor. So we can use synthetic division to help us. Since they tell me that x is equal to negative 2 is a 0, I can use that as my k here. Okay, and then I'm going to have my coefficients here. So I'm going to bring down the 2. Negative 2 times 2 is negative 4, plus 0 is negative 4, times 2 is positive 8, plus negative 7 is 1, times negative 2 is negative 2. So I end up with a 0 here. If I did something wrong, if you get a number here like 10, then you know you did something wrong, because if they tell you that this is a 0, that means that the remainder should be a 0. Okay, so now we take our quotient. Okay, so what is our quotient going to be? So let me go ahead and show you here. So this would be a 2x squared minus a 4x plus a 1. And so now what we can do is notice that your quotient is now quadratic. So since it's quadratic, now you have more options. You can factor, maybe use the square root property or quadratic formula. So you have different options here. So I always try factoring first. And if I can't factor it, then I go to the quadratic formula. But in this example, this does factor as 2x minus 1 times 2x minus 1. So we set each factor equal to 0 and solve for x. So x is equal to half and x is equal to half. Okay, so my degree here is 3. That means that we should have 3 zeros. And so my zeros are x equals -2, the one that they gave me from the beginning, x equals a half, and x equals a half. Okay, so I have 3 zeros. One happens to repeat itself, and that's okay. Remember, when it repeats itself an even number of times, then it touches the axis, the x-axis. And if it repeats itself an odd number of times, then it's going to cross that x-axis. So that was how we use synthetic division. This section is basically to help you to get familiar with synthetic division. And then in 2.5, we're going to use it to find the zeros. Okay. Now, the other thing that we want to make sure that we cover is complex numbers. So complex numbers is a whole number system. And basically what happened is the mathematicians back in the days would try to solve problems like this one here. But then they would run into trouble whenever they ended up with a negative in the square root. So they created a whole number system, and they call it the complex numbers. Okay. So when we get a negative in the square root, in the previous chapter, we would say that we had no real solution. But now we can we can get an imaginary solution with using these complex numbers. Okay. So before we do that, let's see what it means when we graph. If you end up with a negative in the square root, what that means is that your graph doesn't have any zeros. Okay, so the graph is either going to be on top of the x-axis or it's going to be below the x-axis. Now, the imaginary number I, we can define it as I is equal to the square root of -1. And if you were to solve for, if you were to square both sides here, then you would end up with I squared equals -1. So you can remember this part here, I squared equals -1, because we're going to use that to help us simplify some radicals. And then so the complex number standard form is A plus BI. You're going to be asked to write your answer in standard form. And so they want you to write the real part, which we call A, and then the imaginary part, which is BI. Now, in order to have a whole new number system, they had to make sure that the number system met the operation rules. And so you're going to see that here on the next slide. In order to, and what I mean by the operation rules, you have to be able to add, subtract, multiply, divide, just like we would with regular numbers. So you want to add two complex numbers together. Then you add the real parts, which is A plus C. And then you add the imaginary parts, which is B plus D. And of course, you keep your imaginary number I here. And then to subtract, you subtract your real parts, and then you subtract your imaginary parts. However, you can do it this way, or you can just kind of treat them with like terms, kind of like terms. And I'll show you both ways. So if we do letter A, we want to add those together. So method 1 is to use the formula that they gave us, or the definition they gave us in the previous slide. So here I would take my real parts, which is going to be the 3 and the 6. So I'm going to add those together. And then I'm going to take my coefficient of I, which is 1, plus my coefficient of this I, which is 5. So I'm going to add those together. So we get 3 plus 6 is 9, and 1 plus 5 is 6. So that's how we add them there. But maybe for some of us, remembering this in blue is going to be, there's a lot of other stuff we could remember. So you can also add them kind of with the idea of combining like terms. So here you have 3 plus I plus 6 plus 5I. If I drop the parentheses, then I have 3 plus I plus 6 plus 5I. So my like terms here are 3 and 6, which is 9. And then I have 1I plus 5I is going to be 6I. So you can choose either method. Either method will be fine. Okay. If we want to subtract, if you use the first method, then you're subtracting the real parts, A and C. In this case, A is 3 and C is 2. So we're going to get 3 minus 2. And then we're going to subtract the coefficients. So we have a -1 minus the -1 here. And so we end up with 3 minus 2 is 1. A negative negative is positive, so that's going to give me a 0 here. So my answer becomes 1. Or you can think of it as like terms. So we have 3 minus I, and then I'm going to distribute this negative into the parentheses. So I get negative times 2 is negative 2, and negative times negative is going to be a positive I. Combined like terms, 3 and negative 2 is 1. Negative I plus I is 0. So you still end up with the same answer. Okay, so this question here is a very common question for people to ask for help, and so that's why I included it in this presentation. And so here we want to add this together. Okay, so let's see what we get here. So first I'm going to, if you notice, we have negatives inside of the square root. So we want to take care of those negatives. So what I'm going to do is put negative 3 plus, instead of negative 8, I'm going to write it as negative 1 times 8. And that's still the same as negative 8. And then we have 5 minus, instead of negative 56, I'm going to write it as negative 1 times 56. Well, why am I doing that? I'm doing that because I know that I squared is equal to negative 1. So I'm going to go ahead and simplify here. My negative 3 plus my 5 gives me a positive 2. And then for negative 1, instead of writing negative 1, I'm going to write I squared. And instead of writing negative 1 here, I'm going to write it as I squared. Well, why do I want to do that? Well, we know that, let me get my pencil out. If we had something like this, and if I want to simplify here, we know that this is going to give me just I. Okay, and so that's going to be the idea here. And so let me go to the next one. So I have the I squared is going to come out as just I. So I have my I here. And then I have my 8. Okay. And then this I squared is going to come out as an I. And my 56 is going to remain there. Okay. Now, in order to add or subtract the radicals, the numbers inside, which we call the radicands, these have to be exactly the same in order for us to add or subtract them. So you want to simplify the 8 and the 56 to see if you can end up with the same numbers inside. Okay, so for 8, we can multiply it 4 times 2 will give me 8. And notice that I'm using a number that is perfect so that we can take the square root of 4 in this case. Now for 56, I could write it as 4 times 14, or I could use a 2 as well. So let's go ahead and simplify some more. The 4 is going to come out as a 2, and then this 2 stays inside, and then this 4 comes out as a 2, and then my 14 is going to stay in here. Now the 14, I cannot rewrite it so that I'm only left with the 2 in here. So I cannot add or subtract these radicals, and so all I can do now is just simplify a little bit further. If you notice, this term has an I, this term has an I, so I can bring out the I, factor out the I, leaving me with 2 square root of 2 minus 2 square root of 14. And you want to do that because remember your answer, you want to write it as A plus BI, which we have here. Okay, so we're going to do a few more here in a second. So for this one, they're asking us to multiply. So we just multiply the same way that we are used to multiplying two parentheses. So 1 times 8 is 8. 1 times negative 7 is negative 7. I times 8 is 8i. And I times negative 7i is negative 7i squared. Gather your like terms. 8 plus 7i plus 8i is just 1i. And then I squared, remember, is negative 1. So I'm going to replace it. So I'm going to have negative 7 times negative 1. And negative 7 times negative 1 is going to become a positive 7. And then I can add it to the 8, which is 15. And I'm left with 15 plus I. Okay. So let's multiply this one. 17i times 1 is 17i. 17 times negative 7 is negative 119 times I squared. The I squared, we can replace it with a -1. And so now we're left with that. So if we simplify, we're going to have 17I plus 119. In standard form, you want to write it as 119 plus 17I. Okay. Now for the quotient, we have 3 divided by 5 minus 6I. In order to write this in standard form, we're going to have to multiply by something called the conjugate. Okay, so we're going to identify the conjugate from the denominator. And so the conjugate is just going to be the same numbers or the same terms, but we're going to change the operation. So instead of minus, we're going to have a positive. So we're going to take this conjugate and we're going to multiply the numerator and the denominator. So if you notice, I have it written here. And I can do this because if you look at 5 plus 6i divided by 5 plus 6i, then I'm only multiplying by 1. Okay, so we're not changing the problem, we're just making it look different. It's kind of like when a person maybe like puts on a costume. It's still the same person, but now they just look different. So here, this expression here, 3 divided by 5 minus 6i, is putting on its custom, not its custom. I can't say it anymore. Anyway, so let's multiply. So we'll multiply the numerator times the numerator. So we get 3 times 5 plus 6i. And then the denominator, 5 minus 6i times 5 plus 6i. And so let's keep multiplying. So in the numerator, we have 3 times 5 is 15. 3 times 6 is 18i. In the denominator, we have 5 times 5 is 25. 5 times 6i is 30i. And then negative 6i times 5 is negative 30i. And negative 6i times 6i is negative 36i squared. So we can keep simplifying. And then we have 25. The 30i and the negative 30i become 0. And then the I squared, we can replace it with a -1. So we have 25 minus 36 times -1. So that's going to be positive. 25 plus 36 is 61. Okay. So since these terms are always going to become 0 here, a shortcut would be to multiply the 5 squared and the 6. 5 squared is 25, 6 squared is 36. And so then we end up with 61. So we're going to go ahead and simplify some more. So 15 divided by 61 is 15 divided by 61. And then 18 divided by 61, we get 18/61's I. So this is going to be our standard form. Okay, so on the next one, it says right in standard form, we're trying to add these numbers together. So remember, you have a negative here. So always get rid of those negatives first. And we can get rid of the negative by rewriting it as a -1 times 75. Still gives me -75. And -1 times 12 gives me -12. Well, the -1 can be replaced with your I squared. Okay. And we want to do that because the I squared, if you take the square root of I squared, you're just going to end up with I. So we have I square root of 75 plus I square root of 12. Can I add these together? Ruben, can I add those together?
Not the way it looked right now, but we could simplify it and possibly, because the only way we can
Okay.
add like terms is if they have the same radical, correct?
Yes. All right. So how could we simplify that 75? You want to think about perfect squares, right? So,
Yes, or we can do a factor tree.
oh, you want to show us your factor tree?
Oh, sure, I'll show you my factor tree. So let me get a pen here.
Especially since it's spring, right? It's time for planting and everything.
Right? And you can probably hear in my voice, I'm been suffering from allergies with all this wind. Um, but for me, the way that I would look at this is let's look at the 75 first. So if I have the 75, um, the square root means that I want to make pairs of numbers. So since this is an odd number and it's divisible by 5, what I'll do is I'll do a factor tree of 5s. So I'll divide this 75 by 5. So 5 divided into 75. So 5 will go into 7 one time, remainder 2. 5 will go into 25 5 times. Okay, so 5 times 15 gives me the 75. So I have a prime number now, which is 5, but 15 is still a composite number. So I can divide this 15 by 5 again. And this one is a easier one. 5 divided by 15 is 3, right? So 3 times 5 gives me 15. So the, com the composition of 75 are the multiples of 5, times 5 times 3. And again, square roots is all about making pairs of numbers. So I see that I have a pair of 5s. So in reality, I to the square root of 75 can be written as I 5 to the square root of 3, which is what was left over. Okay, and I can do it again. I can do the same thing for the 12. I can do what's called a prime factorization tree. And since 12 is an even number, I'm going to divide by its first prime even number, which is 2. So I'll divide by 2. 2 will go into 12 6 times. So 2 times 6 is 12. So I got my prime number 2, but 6 is a composite number. So I can divide 6 by 2 again. So 2 divided into 6 is 3. So 2 times 3 is 6. So the composition of 12 is 2 times 2 times 3. Okay, so since again, square roots is all about making pairs of numbers, I have a pair of 2's. So this I to the square root of 12, I can rewrite it as plus I 2 square roots of 3. And now I see that I have two like terms. They both have the same radical.
Thank you, Ruben. Those were really pretty trees. So let's go to the next slide so you can see what the final answer would be. So again, as Mr. Carizales said, we rewrote this as 25 times 3 and 4 times 3. Well, the square root of 25 is going to be 5, right? And so we ended up with 5i square root of 3 plus 2i square root of 3. Since the radicands, the numbers inside the square roots are the same, then we can add the coefficients in front of those square roots. So 5i plus 2i is going to give us 7i square root of 3. So you want to make sure this is in standard form, so there's no real part to this. So we end up with 0 plus 7i square root of 3. Okay, so let's go to the next one. You're going to be asked to solve the quadratic equation using the quadratic formula. So the quadratic formula is written right here, x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. And these a, b, and c, these are just going to be your coefficients in front of your terms here. So a is always in front of x squared. In this case, there's a 1. So a is 1. And then in front of x, we have a negative 2. So that's your b. And then your constant is c. So if we plug that into the formula, then we end up with negative b. B again is negative 2 plus or minus negative 2 squared minus 4 times 1 times 2 divided by 2 times 1. So we're going to go ahead and simplify. And so we end up with negative negative is a positive 2. Negative 2 squared is 4. Negative 4 times 1 times 2 is negative 8 divided by 2. So 4 minus 8 is a negative 4. So we end up with negative 4. So it's a negative. So again, you can take care of that negative by taking out, rewriting it as negative 1 times 4, which is going to come out to I, because remember we get an I squared, and then the I squared comes out as an I. And then we can simplify. The square root of 4 is a 2i. And then we can divide by the 2 here. So 2 divided by 2 is 1, and 2 divided by 2 is 1. So my final answer here, I can write it as 1 plus or minus I. Okay, so what this tells me is, since I ended up with an imaginary solution, this graph right here is going to be above the x-axis. So it's not going to have a 0. Okay, so I believe that is the, so one answer here is x equals 1 plus I, and your second answer is x equals 1 minus I. And so for WebAssign, Mr. Carizales says to enter your answer with separated by a comma. Okay, so that was it for these two sections. Next section or next week, we're gonna be covering 2.5, which is actually one of my favorite sections because we get to put everything we just did in the last 3 sections together to find these zeros, and then to graph something that is higher than a degree 2. And so
Very
I
good.
will pass out, and also Mr. Carizales said he agrees, so
Yes, I
he
do.
likes the section too. And then I think we also get into a little bit of the 2.6 section, which is graphing rational um, equations, but we'll see how far we can get. So I'll pass it over back to Miss Patricia. Have any questions? We have tutors here that can stay and help you. I'll still be here for like another 10 minutes or so. So if you have any questions, please let us know. Please make sure to sign in that you were here, just so that we can make sure that we let your instructors know.
Yes, thank you, Ms. Chuka and Mr. Carizales, for your wonderful presentation. We do want to remind everyone that our previously recorded sessions are available on a YouTube playlist. This video will also be available on that playlist later on today. Also linked is a short survey to help us improve our TVE sessions. Please take a few minutes to fill out that survey and another short survey to receive credit for attending. Thank you all for coming in today. And before you leave, we do want to share with you guys the sessions that will be available next week. So there we go. So next week at 1 p.m. we will have Fitness by Jeremy Perales, sorry about that. And at 3 p.m. we're going to have Happy Math Hour. So for 1314, it'll be finding zeros of polynomial functions. And for 1324, it will be simple and compound interest annuities. We hope to see you guys all again next week. And if you guys have any questions, please let us know. Please remember to fill out those surveys. And we hope that everyone has a lovely weekend. Thank you, everyone.